Hello everyone, in statics we are going to see about a lambda mu theorem based on a problem. So the five forces acting at a point are represented in magnitude and direction. In order that five forces means we choose, if we have three forces means we choose a triangle. If we have a four forces means we may choose a square or a rectangle or a parallelogram, likewise else. So here five forces are acting at a point. So here five forces are a pentagon. This is in the form of pentagon. So pentagon we have five forces. So that could be represented as A vector, B vector, C vector, D vector, E vector in magnitude and direction by the lines joining the vertices of any pentagon to the midpoint of their opposite side. So if we take this A vector means this could be joined to the midpoint of the opposite side of that vector. So if we take A means the opposite side is this one. So in between D and C we mark that vector, that is P vector. So marking all like that show that they are all in equilibrium. So equilibrium means all forces are equal to 0. So we put that here A, B, C, D, E. So opposite of A is DC. So we put here P vector, and opposite of B is ED. So we frame here Q. Then opposite of C is EA. We put here in between that EA we put R vector, and D we put it in between A and B we put S vector, and also likewise also E. In between EB we put T vector. So what we want to prove here, we want to prove that AP, that vector along the one side point under one vector. So AP vector plus BQ vector plus CR vector, that one line CR vector, then DS vector, ET vector, that all are equal to 0. That show that this all are in equilibrium. Equilibrium means 0. So we have to prove this form equal to 0. So let we take that here having a AP. So we take this triangle, that is A points A, D, C. So here A could be plotted here, and D here, A, D and C, and P in between, that lies in between D and C. So if we use a lambda mu theorem, according to lambda mu theorem, so it can be written as 2AP, that is 2 times of AP equal to AC vector and AD vector. So here having a AP. So if we take AP means that 1 by 2 come here. So 1 by 2 AC vector plus AD vector. Likewise also all the rest 4. Then take B. So B here and ED, this term ED and B. So Q here. So if we use lambda mu theorem means we get BQ equal to 1 by 2 BD and BE vector. Likewise also third. So third one is C here, C and EA. So EA and in between R vector. So it can be written as CR equal to 1 by 2 CA vector plus CE vector. And fourth one is DAB. So DAB in between S. So it could be written as DS equal to 1 by 2 DA vector plus DB vector. And also fifth one is E. So here E having, and here CB. So CB it could be formed as ET equal to 1 by 2 EB and EC. So we found that according to the lambda mu theorem, we formed such a formation according to that given proof. So here AP having a 1 by 2 AC, all terms having 1 by 2. So we take 1 by 2 as common. Instead of AP, what we have? AP 1 by 2 is taken as common, the rest term is AC plus AD. So we put AC plus AD, and instead of BQ we put BD plus BE. So BD plus BE and C, or CA plus CE. So CA plus CE, and DS could be written as DA plus DB. So DA DB, and ET can be written as EB and EC. So EB and EC. So we want to prove that these terms are in equilibrium. So R, see here, R, AC and CA are here. AC is denoted as 1 and CA can be denoted as -1. So in the form of 1 minus 1 means this term goes to 0. So these are equal. AC and CA are equal but in opposite direction. So opposite direction, so it could be cancel each other and getting 0. So AC and CA getting cancelled, and AD and DA, and BD and DB, BE and EB, and EC and CE. So all the terms are getting cancelled. So what is 1 by 2 into all the terms are getting cancelled means we have 0. So 1 by 2, 0 equal to 0. So we proved that all the forces are in equilibrium. So this is the solution for this question. Hope you all understand, and thank you.